Director GHRCE College of Engineering, Dr. Presubmission, Supervisor Dr. Mauni, Dean R&D Dr. U.S. Mankhede, faculty members and dear students, a very good morning to all of you. I am Shivani Girimunje, Associate Dean R&D, feel privileged to welcome you all to the PhD Presubmission Seminar of two PhD scholars of Electronics Engineering Department. Mrs. Soni Chaturvedi, Electronics Engineering Department, on topic reconfiguration of spiking neural network for optimization with application to image processing. And Mr. Rakesh Agarwal, Electronics Engineering Department, on topic advanced techniques for classification of remotely sensed images. Dr. Praveer Kumar Biswas is Professor and Head of Department, Electronics and Electrical Engineering Institute, Indian Institute of Technology, Kharagpur. His research interest is image processing, computer vision, automated visual inspection, multimedia network, pattern recognition, sensor network. He is a senior member of Institute of Electrical and Electronics Engineer, USA. I would like to invite Dr. Presubmission to present floral bouquet to respected guest, Dr. Praveer Kumar Biswas. Thank you, ma'am.
Kan bukan lah. Jalan kau. Apa pun. Nasi kan tu tu. Baik cuman.
I would like to explain the title of my PhD. Reconfiguration of spiking neural network means to remodel or restructure the spiking neural network for optimization, that is, which means that by providing an alternative for maximizing output and minimizing error for image processing. This is the outline of my presentation. I'll brief you about the title, problem statement, review of literature followed by objective, phase-wise explanation and results, modifications done by me, and further implementation of modified algorithm along with conclusion and future scope. Artificial neural network is similar to biological neural network. Is a computational model which updates its network by the change of input and output. The spiking neural network falls into the third category, third generation of neural network, wherein which it considers the spike timing for its coding, which means that the neuron of spiking neural network, they fires or they generate an output spike only after it crosses a threshold on application of input injection current, which means that when membrane potential exceeds the threshold, an output spike may be generated. But they have the advantages of faster information processing, accuracy, as well as adaptability for varying the model. Next, and also they are feasible for hardware implementation for optimizing the speed, area, and power. Hence, the problem statement we can define as to design and implement an efficient method for addressing conflicting objectives of higher efficiency and reduced computational cost with application of pattern recognition using spiking neural network. These are the literature survey. Many researchers have discussed.
Your thesis title is for image processing.
Pardon, sir?
Thesis title is
yes, image processing. Yeah.
And your you are saying pattern recognition.
Sir, when I registered during my first progress seminar itself, expert from VNIT suggested me to proceed for image processing. Under image processing, he asked me to divert for computer vision. Under computer vision, I took up an application of pattern recognition.
The problem statement says it is pattern recognition.
Yes, sir.
Whereas this is titled as image processing. Image processing and pattern recognition, these are two different aspects.
Sir, with application to image processing, the title is
Right.
okay. Under image processing,
But the back you have to clarify properly.
yeah,
Your thesis title to problem definition, then
Yeah.
you write two paragraphs.
okay.
Then why don't you make thesis title as pattern recognition?
Sir had suggested me to go for an application.
When the candidate register, the thesis title, it gets analyzed in that RRC.
RRC.
So it cannot be,
That is not correct. That is not correct.
it is part of university jurisdiction, so college.
Because the problem is such that during the research or the problem gets defined. So this is title should be finalized at that this time. That is the problem.
Since it is under university, we do not have any say as far as the title of the.
Okay, in that case, I'll say that your problem definition instead of calling as pattern recognition, I mean, what kind of
Fine,
pattern
sir,
recognition
yeah.
problems you have tried?
Yes,
That I
yes.
want to see.
Actually, the Dr. Keskar always used to come for my progress seminars, 6 months progress seminar, and he suggested that image processing is lot of researchers are there in that field. So I would suggest you to go for a pattern recognition, pattern classifier application. Under same category, you can continue. So,
No, what are the kind of patterns that? See, patterns can be a lot of patterns.
yes,
Say for example, when you run a machine, the machine generates a pattern.
yes.
When you are speaking, okay, we are also generating patterns.
So I have taken specific example of character recognition, handwritten character recognition.
So I think in your problem definition you say that.
Okay.
Instead of
Okay, sir.
pattern recognition.
I will discuss.
So instead of simply saying pattern recognition, you can say image pattern recognition.
Image pattern.
So the patterns that you are talking about, those are visual patterns,
Sure.
not other patterns.
So many researchers they mentioned about coding of analog signals, and then how this SNN models work. What are the basic principles involved for information coding through spiking neural networks? And ultimately, after reading all these literature, I learned that out of various models of spiking neural network, two promising models, LIF, that is leaky integrated fire neuron model, and Izikevich model are the most commonly used because of their significant features. Although other models have their own significance, but these two models, leaky integrated fire as well as Izikevich model, they are the most promising model for exploring this work, proposed work. Next, please. Many researchers I have already discussed. Few of them also had advanced their work for character recognition. Few of them also carried out their work for hardware implementation and so on. Next, please. Next. So, leading to an objective of proposed work, which is to develop framework for solving spatial and spatio-temporal problems, to conduct experimental analysis of spiking neural network with existing methods and evaluate performance, simulations of the proposed framework using reconfigurable platform, FPGA, and application-specific integrated circuit. This is the timeline of my proposed work. After literature survey, I delivered my introductory seminar.
These you can speak now.
Okay.
These are the things which are already done.
Fine.
Now you are at the final stage.
Okay, sir. Next, please. This was the first module of my work. simulation of leaky integrate and fire model, wherein which we can see that similar to biological neural network, we have a parallel RC circuit on application of input current. The current across the capacitor exceeds the threshold. Whenever it exceeds the threshold, an output spike may be generated. So these are the simulation, MATLAB based simulation results of LIF. Another promising model, as I discussed, is Izikevich model. What he did was he combined best properties of two different models. He took a biological plausibility of Hodgkin-Huxley and computational efficiency of integrate and fire neuron model, which is also a model of spiking neural network. And he combined best of both and came up with a modified version, which was very much useful for improving the speed or for optimizing the accuracy. So this is the Izikevich equation. These are the two output equations. We can see that whenever threshold membrane potential crosses 30 millivolts, an output spike is generated, where A, B, C, D are the dimensionless parameters. Small u and small v are the membrane potential and membrane recovery variable respectively. A, you can call it as time scale of recovery variable, B is the sensitivity of the recovery variable, C is after reset value of membrane potential, and D is the after spike reset of recovery variable. The advantage of using this model is just by altering these parameters, we can generate different variety of patterns required for our application. So, continuing with the phase-wise modules, I started with image segmentation by k-means, wherein which, previous please, wherein which an image is red, it is then converted into either grey or a color image mapping may be done. Then we form a matrix. Different clusters, they were formed using k-means algorithm, and outputs were obtained, which would be shown in the future slides. Further, I used ANN also for image segmentation, and then I applied spiking neural network for our image segmentation. What I did was I obtained I referred some few existing simulations, and then I compared my results with the earlier studies output. Next, please. So these are the results. We can see more, please. Next. These are the segmentation. We can see that we are having 3 clusters. Different cluster objects have been segregated using k-means method. Final one is your segmented image. Using spiking neural network, we must deal with 3 major issues: the network architecture, the information coding, and learning method. Network architecture, which I proposed to use, was fully feed-forward network, and information coding in SNN are of 3 types. First is rate coding, then we have temporal coding, and then population coding. Rate coding is depends upon the firing rate, while temporal coding depends upon the firing times, and learning method here we have used is Hebbian winner-take-all learning method for training and for learning. So these are the segmented output for SNN based model. Having the MATLAB code also, I can show you the outputs after execution. Next please. More outputs. I have taken this data set I have taken from standard data set of Berkeley image segmentation data set. So for reference, I have taken variety of colors, variety of this. More segmentation outputs we can see. Next please. Next please. Purposely I have taken more bright, more some light and grey, and like that I have executed my results. Next please. Next please. So I would like to mention what are the parameters or evaluators I have considered: mean square error, mean absolute error, peak signal to ratio. These are the 3 parameters for which I have considered the results using k-means, ANN and SNN, and I have compared the same with my obtained results. Now accuracy, fitness function and simulation time with reference to the pattern classifier of character recognition. Again, for reconfiguration the part, I have used the specifications as simulation time, power and area, in our, which would be highlighted in our future slides. So we can just see the performance for k-means, ANN, SNN segmented outputs earlier, which I showed. We can see that the segmentation is quite good with k-means also, but with the ANN approach, it has been enhanced, and SNN with the use of temporal axis improved the results as compared to. Next module was pattern classifier for character recognition, as I discussed. The steps involved are, we must read an image. For any pattern classification, we must do the pre-processing which further includes image pre-processing, wherein which we smoothen the image selected using, I have used Gaussian filter, and then after smoothing, we try to extract, detect the edges, and for after edge detection, we get the feature values. Those feature values are processed as input. They are further fed as input to the neural network, and after processing we get various classes.
At which stage you are using the filter?
Pardon, sir?
What filter
Huh.
stage you are using?
I am using for this edge detection. For feature extraction, I have applied Gabor features, which has multiple frequency components and orientation feature theta. So those, again in that we have magnitude and angle images. I am applying for extracting features. I have used Gabor filter.
The thing is, after any algorithm, you are getting only the edges.
Yes, yes.
And the rest of the part of the image is black.
Yes.
So you have single pixel white information after any edge detection. After that, if you use Gabor filters, what kind of information Gabor filter will give?
The output, when after detecting edges, we get feature
Your
vectors.
informations are all localized. Right? After edge detection, the information becomes localized in the image.
Yes, but we have extracted the features of our interest. Those features we have.
But your interest is limited to 1 pixel. The moment you are doing edge extraction, particularly with algorithm like Penny's algorithm,
Yes, sir.
your region of interest is limited to 1 pixel.
But I am getting more feature vectors, sir.
No. See, you are using Gabor filter, depending upon the number of orientations and scales you use in Gabor filter, you will get a number of
Yes.
features, right?
Yes. So
The
I am
number of
applying.
scales multiplied by the number of orientations that we use.
Yes.
But
G
what
of
is-
x comma y.
But what is the physical significance of it?
Sir, those feature values basically they are pixel values that individual pixel value tells you the brightness or
After edge detection, it is a binary image. Pixel value does not have any meaning anymore. It's a binary image now. Whether you have an edge there or you don't have an edge there, that is the only information it has. Okay, after edge detection, the pixel value does not have any meaning. It's a binary image. In other words,
but I am getting different
you will
feature
get
values.
something.
Yeah.
Something you will get. Definitely
So
something
those
you will get.
those are the remaining feature values, remaining feature vectors, sir. Not all. Those feature vectors I am giving as input to our neural network for further classification and processing. I can execute and show you.
It will give something, definitely.
Yes.
But what is its physical significance? That is what I am trying to find out. Gabor filter after its detection, what does it give?
It gives a number of feature vector values. In MATLAB coding, I am able to generate those feature values.
If I totally avoid this scanning algorithm, don't use scanning algorithm at all. I apply Gabor filter over your smoothed image.
Yes.
How much difference do you get in terms of your character recognition? Did you try that?
Directly you want to apply.
Direct, without edge detection.
But sir, we have to have certain features for.
Even then you will have features.
So that depends, that varies from one application to other application.
No,
But what is your?
I am talking about this application only,
Okay.
character recognition application only. If I just remove this edge detection stage, apply Gabor filter on the filtered image, and then try to recognize the characters. And after applying this,
We'll be having magnitude images and angle images pixel values. Magnitude images, angle images pixel value along with that h of x comma y comma theta. Theta is that orientation. And then we are using, yes, we can use a set of Gabor filters.
obviously when you are using Gabor filter, you have to use set of Gabor
Yes,
filters.
filters
A
for-
single Gabor filter does not have any significance, it does not have any meaning.
Yes, set of
Gabor
Gabor
filter is to be used in a set
set in order to.
at different scales and different orientations. A single Gabor filter does not have any meaning. So I want to see that.
Okay.
If you remove this scanning algorithm part or edge detection part, then what you get? With scanning edge detection algorithm, what you get and what is the difference between these two?
These are the recognition. Now, as I discussed, I applied I have used artificial neural network based character recognition, where in which we are able to, I have created a GUI, I have tried to obtain various results, and further I have used spiking neural network for the same set of images. Sir, this is for information that I have used 30 samples for each character, minimum 30, maximum maybe 50 or 60. So minimum 30 and samples of individual character, uppercase, lowercase, digits, as well as special characters. Then among SNN also I have used two different models, LIF, that is leaky integrated fire model, and EasyKVIC model. So we would try to compare the results, and if the results are not meeting the expectations, we further proceeded for modification of the algorithm or modification of the EasyKVIC equation in order to achieve the required results. So these are the outputs for ANN based character recognition, again for small b and capital B. Next please. These are the output characteristics, output spikes obtained using leaky integrated.
What is the recognition output?
It would be spike, output spikes.
No, when you are recognizing a character,
Yes sir.
right? How do you recognize it? You are giving an input pattern, right?
Yes.
So these are possibly handwritten patterns.
Yes. Various stages, pre-processing stages.
I forget about all this.
Yes.
I assume that your entire set of stages is a black box.
Yes.
Input is your handwritten character.
Yes.
What is the output?
Output, when I use spiking neural network, I will be getting output spikes. One each different pattern for each individual character. And for all 30 samples, it should give single pattern, just to classify. There are 26 alphabets, uppercase plus 26 lowercase, 52, 10 digits, 0 to 9, 62, plus 9 special characters, 71. So 71 different spike patterns, one each for individual character, are to be generated. And if we take 30 samples, maybe out of that 27 are giving me the similar spiking behavior, and 3 samples are not trained well. So the efficiency could be 27 out of 30. It is not the case that every time I input a character, it is identifying the character every time. The efficiency is not 100%. Many cases it may be 90%, maybe 60%. So it depends on the training. And we have considered the test data set, training data set, and separately, sir. For example. Next, please. More results for lowercase alphabet. Next, please. Next, please. Sir, I have also considered the invalid input, wherein which it gives a not match message. So we can conclude that pattern classification of uppercase and lowercase English character using easy-cubic neuron model of spiking neural network has been achieved. The focus is on spiking mechanism in terms of accuracy and simulation time. So we must compare the results of all the 3 methods. Next, please. Again, for digits, these are the feature vectors which I have got. I was discussing about these feature vectors after applying Gabor filter. Next, please. Easy-cubic model based. Again, now.
How do you compute these feature vectors after the Gabor filter?
Sir, using MATLAB simulation.
That is a tool.
Sir,
Whether
okay.
you are using MATLAB or you are using LabVIEW or you are writing in C, that is immaterial.
Okay, sir. So you are asking the process.
How are you computing the feature vector after applying the filter? That is not. How you implement that is not.
Okay. So this Gabor filter, this whatever. See that formula is there, sir, for g of x comma y. We are using, sir, it follows Gaussian distribution, which is used as a low pass filter, which may be treated as a low pass filter.
Is it only Gaussian? Only Gaussian is not Gabor. It has a Gaussian envelope modulated with sine wave.
Yes, yes. I forgot to mention, sorry. It has to be modulated with sine wave, yes.
The envelope of the Gaussian envelope that is characterized by sigma.
Yes.
Which is the scale.
Yes.
Right? There is another term omega.
Omega.
That is the frequency of the sine wave. And there is one more parameter which is theta, which is
Theta,
represents
orientation.
So when you apply this Gabor filters, how are you computing the feature vector from the output of the Gabor filters?
Sir, we have taken 2 frequency components, F1 and F2, and
How many scales?
theta n, I have taken n equal to 6, and theta is also n pi by 6. I have calculated it.
That is not mentioned anyhow in these cases.
This is not. So this is rough draft. Maybe by mistake. It is not mentioned. Okay, I will check it. Maybe check the summary. It is not there. But this is no. This is rough draft of thesis. Maybe by mistake it is there. Next, please. For digits and special character, we have used again the same all the characters. We are further comparing with artificial neural network, spiking neural network, lift model, and easy-cubic model. These are the different, sir. These are the sample input images. So I am having the database of each single character with 30 to 60 samples in the range of 30. So I have also used few special characters, almost 9. These are the results for again identifying the digit and the output. These are the feature vectors, the neural network training, the snapshot along with the recognized by FFN and then recognized by easy-cubic. After easy-cubic we are getting this output. Next please. So when we compare results for a single character B, we find that the Izhikevich model, though the efficiency of leaky integrated fire model and Izhikevich model are almost same. As I had said, that every single model has its own significance, we cannot remove it. Though the frequency, the efficiency or accuracy is same, but the simulation time is much more reduced in case of Izhikevich model. So after comparing these results based on ANN approach and SNN, within SNN two different models, existing methods, I decided that, or I concluded that Izhikevich model should be the best choice for further work of my research. So I thought of modifying it based on the parameters A, B and C, D which are defined earlier. Next please. I'm extremely sorry for this repeat slide. This need to be mentioned here once again because we are trying to modify this U dash and V dash equation, which is the work contribution of my research. Next please. So the modified equation details can be, I considered a linear relation between A and B. So it is given as B equal to AX. When we substitute this value in the equation number 1, what we observed, I substituted different range. A, B, C, D have their defined ranges. I tried to choose these values randomly and I found that the number of output spikes was increased just by varying these two variables. Next please. So actually the firing rate, what we are interested is in, we require more very high frequency outputs. That means more number of frequency outputs will reduce the processing time. Okay, so which is dependent on the parameter firing rate. Firing rate is nothing but the total number of output spikes generated upon time period of input synaptic current. Okay, so now when we increase this numerator term, number of output spikes produced, if we increase this, so automatically our firing rate will increase. So when firing rate will increase, automatically we will get higher frequency output spikes, more number of spikes in the output. Okay, so and in turn accuracy will improve, because from the literature survey and from my previous experiments I learned that just by increasing the firing rate we can increase the accuracy. So more the number of spikes in the output, more will be the firing rate, so faster will be the processing and accuracy will also be increased. So these are the just a sample table I have introduced. Just by preserving this relation of B is equals to AX, value of A, value of B, value of X, I will show you the snapshots of the output. That this A, go ahead please. No, forward please. More number of output spikes are being generated. So I applied this modified equation for simulation of character recognition, and after applying this, the results were further improved in terms of efficiency or accuracy you can say, and then simulation time. Again, more results I have displayed for 1/4 digit. I am having lot of results, but due to limitation of time I am not able to. So we can conclude that the modified equation, Izhikevich equation, it permits us to raise the firing rate, which in turn will increase the accuracy further. Hence the proposed model shows faster processing with increased accuracy. Next please. For validating my results, and I concluded that Izhikevich model performs the best among the 3 models, out of the 3 models, ANN, SNN as well as within SNN, 2 different models I have used. Out of the 3 models, EasyKV was most suitable for character recognition. And one of the literature survey also guided me to develop the framework on reconfigurable circuits. So I decided, go ahead please. So I decided to go for hardware implementation of the proposed algorithm. Since they have the optimal characteristics for hardware implementation, these the models, they communicate among themselves through spikes. So when we use such kind of communication, we can see that the number of logic resources, they get reduced, and then in turn we can reduce the logic operations required within any device. So I decided to implement the same on FPGA using this EasyKV model for improving or optimizing accuracy, power and simulation time. So these are the results obtained. Again, same set of data, same characters were used. Those 30 samples of 30, maybe 40, maybe 50, they were used for the using EasyKV model, and then different patterns of spikes were obtained for FPGA implementation output on DSO. Next please. Spike produced for capital E&E. It also provided an optimized filter summary. I have used the tools quarters 2. Resource utilization on FPGA for the same algorithm. It provided less number of logic elements with increased accuracy and reduced power and reduced timing. Same I have further carried out my work for implementation of ASIC, that is application specific integrated circuits, which previously used the design the power compiler, which used the power compiler for which used the clock gating approach for minimizing the powers. So we can say that successful FPGA implementation of character recognition based on modified EasyKV model has been achieved, and it shows significant speed-ups over equivalent software implementations. Now for ASIC implementation, as I discussed, we try to reduce the power, and also we try to obtain the RTL view based on Synopsys tool. Next please. So these are the design flow for ASIC, wherein which, as I discussed, I am using the clock gating approach in order to minimize the power. So now this is when I compared the results for ASIC implementation, I achieved optimized output on 90 nm, selected feature size is 90 nm. Tools used was Synopsys design compiler. Next please. This is the layout of generated EasyKV model which I received. Tools I have used through for my work are, next please, MATLAB, Synopsys. So overall conclusion and cumulative findings, we can see that it exhibits 5 to 10% improvement in mean square error, mean absolute error and peak signal to noise ratio as compared to feed-forward architecture, because spiking neural network overcomes the computational power of neural networks made of threshold or sigmoidal units by adding the temporal axis as new dimension. Design of classifier for character recognition using various models of spiking neural network and modified EasyKV have been considered for comparison of fitness function and accuracy. Cumulative results also exhibit improvement in the fitness function for up to 25 to 30% and for accuracy 10 to 15%. So handwritten character recognition has been achieved using modified EasyKV model. It classifies different characters and can be implemented on FPGA and ASIC. The proposed system successfully attained the optimized output in terms of speed, area, power based on FPGA and ASIC implementation for handwritten character recognition. Also, the RTL layout for the complete design using Synopsys to achieve power and area analysis has been obtained. These are the publications. I have a book chapter to my credit in the Springer edition of Alan Turing. I presented a poster at IIT Powai. Next please. My CIIT journals, CIIT Journal of Image Processing, and also IJET-CAS. Next please. I have 2 conferences recently. I have publications which are associated with Elsevier and ScienceDirect.com. I presented this paper in USA recently in California, Berkeley University. Next. Another one was in Shenzhen, China. This is to be published in the lecture notes of electrical engineering under the Springer edition. Another one for this CSRI EA Press. This was also an international conference. Next please. These are the references. Thank you, one and all.
Can you explain the various stages of, so the first one will be the image segmentation.
Yes.
Yes, through your presentation it was not clear to me. So what are the various stages of image segmentation?
Various stages of image segmentation is to read an image first. Okay. After reading an image, we must process the image in order to obtain the segmented output. Okay. So first and foremost, we must divide it into clusters. We must do the cluster. We must apply the clustering techniques in order to classify similar objects in one group or in one cluster. So after applying this clustering technique, what we can do is we can now after application of this K-means clustering, for example, we get different blocks of similar objects in one cluster, and then this is applied, this may be trained using ANN in order to classify different segments.
No, in your work what you are doing? Using your spiking neural.
Yes, using spiking neural network.
Why are you using spiking neural network? What does the spiking neural network give?
Sir, because of I want to obtain improved accuracy, more enhanced outputs. The spiking neural network, I have already discussed that there are 3 major issues when we go for segmentation based on the spiking neural network, wherein which the first key parameter is the network architecture selection.
No. Well, suppose we have selected the architecture. Then how does the spiking neural network help in segmentation of an image?
Okay, sir. So now spiking neural network, we consider any one model. So that particular model, it is nothing but similar to artificial neural networks, 3rd generation neural. So we must apply the test input to train.
What is the input?
Input would be pixel values, sir. Pixel values, and then they are to be trained. After training, it is to be classified that this particular belongs to this particular class, and then it must recognize. These are different levels of.
So how is it working?
So that learning, we are applying certain algorithms for learning and
I'm
training.
asking for that algorithm. Don't give me black boxes, right?
You want to know the algorithm.
Yeah.
That is Hebbian winner.
Know where in your thesis your algorithms are clear.
Hebbian winner take all algorithm is the one.
Nothing is clear in this.
Okay. Okay. That is, sir, wherein which out of these output neurons, Hebbian winner take algorithm means which one fires in the first, that will be the winner. So that is what is the concept.
Okay, so is it simply based on the pixel values or you are doing some pre-processing and getting some features?
We must do some pre-processing, sir.
What is the pre-processing?
Again, same color to color mapping could be done for pre-processing. Smoothing, we can apply filter. We can apply filter for smoothing, and then again same feature extraction part, and those features are then processed using this particular algorithm for learning. Actually, sir, I had involved it, but it was those formulas were plagiarism check में आ रहा था, standard formulas उसका जो standard algorithm है, उसको अपनी own words, उसकी वजह से मैंने थोड़ा सा उसको shuffle किया. I'll add it definitely, but Hebbian winner take algorithm, if I have to explain, that's a standard algorithm, so it was accepted in plagiarism. So I had to, I'm having the old draft of my thesis also, where it was so these are the publications. This is a in Shenzhen, China, World Conference on Network Analysis. It was in December.
Here you have must be important your technical implementation of
Yes, sir. I have, whatever algorithm I have modified, I synthesized it on FPGA and then observed the output on DSP.
my suggestion is
Yes, sir.
when I go to your thesis, your thesis has clearly two parts, right? The first part is the algorithm and the last chapter is on FPGA implementation.
Reconfigurable framework.
Right. Now, when it comes to the algorithms, you have to clearly state how you are extracting the features and using the features for recognition or segmentation purpose, which is not there in the thesis. What are the features? How you are extracting those features? What is being inputted to your neural network?
I
As-
have mentioned those edge-detected feature vectors
And secondly, what I asked, I mean, using Gabor filter after edge detection and using Gabor filter before edge detection. Because according to me, Gabor filter after edge detection has no meaning. Okay. Because once you do edge detection, particularly with Chinese edge detection, right?
Yeah.
Your entire information is localized in a single pixel. And above filter on that, what extra information is it? The other characteristics are lost the moment you go for edge detection. Then output of your spiking neural network. As you said, the spiking neural network is giving you the spike characteristics, right? Using which you are going to classify, you are going to order, you are going to segment. So whether that classification or segmentation is being done in the neural network itself, or you have some post-processing.
Post-processing?
That is not mentioned. What kind of post-processing you have done? Your thesis does not say that. The results that you have obtained, those are not properly analyzed. Simply saying that I have done this, I have got this result, nobody will appreciate it. The results have to be properly explained and it has to be properly analyzed. Okay. Again coming to your thesis organization. You have small chapters. In one case, your list of reference is more than the number of pages in the chapter, possibly in chapter 2 or chapter 3.
It is literature survey, list of references.
List of references, right? So your list of reference, the number of pages for that is more than what you have discussed on that literature. When you go for literature survey, you have to say something about what has been done in that work, in that particular publication. What is its drawback? What is its merit and what is its demerit? That you have to say. Right? And the way you have written, first one is literature survey, then you have talked about your spiking neural network. I'll suggest you combine these two. Because you are giving emphasis on spiking neural network. Right? So you can make a chapter like spiking neural network and related literature, something like that. Okay. Then references you have given after every chapter. In some cases 1 reference, some cases 2 references, some cases 3 references.
Which are the main ones? The overall references are at the
So
end.
why don't you have a single reference
So
at the
was
end?
the format of
The university format? That was after every chapter?
yes, that is
I don't
fine.
know.
Actually, I had written after first revision, I got suggestion. Just main after at the end of every chapter. If you say I'll remove, no problem.
Because
I've already
no,
put
if
the
it is
complete
your
text.
university format, then I should not say that you don't do it.
Yes, sir. If you say I will add complete.
Well, that does not look good. Having only 1 or 2 references for a particular chapter, particular chapter, it does not look good. Okay, so your thesis has to be thoroughly rewritten. In this form, this thesis should not be submitted. Okay.
Okay. With this, I think you must have been benefited immensely by attending these pre-submission seminars as far as your stream of electronics and VLSI engineering is concerned. I am thankful to Professor Praveer Kumar Biswas for traveling long way from IIT Kharagpur, then Kolkata and then to Nagpur and spending some 2 days for this very event to happen. And I expect the PhD scholars to incorporate all the suggestions in their work so as to improve the quality of the PhD thesis and work as a whole. Thank you once again.